So thank you for waiting. So and thank you very much for coming to Sony Osaka City in Tokyo. And I'm very happy to be here. And today I'm talking about the status updates for NuttX ARM64 on QEMU plus hypervisors. And about me, maybe it will take this time is short. So I did develop so many products before, so including Linux Workman and Android-based Workman, and then we this as you know, NuttX-based audio recorder as well as headphones. And recently, I'm doing feasibility studies and doing some presentation at the Embedded Linux conference as well as a NuttX international workshop. So this is today's agenda. So first, let me introduce the last activity at NuttX 2023. And then I quickly review the hypervisor and the KVM, which you might know. And then I will talk about the NuttX target comparisons, including emulator and simulator. And then I talk about how we can run a Bravio sound with and without USB audio device. This might the reason why we use these two types of devices configurations. You will see the reason later. And then I will show you how we can use perf command with NuttX to trace guest OS. And finally, I will show you demo videos. So this is a slide from NuttX 2023 last year. So happened in Brazil. So I visited Brazil so first time, and I talked about this slides in Brazil. And at the time, I introduced how I implemented Bravio MMI.net as well as Bravio block devices. And this is the right side. You can see here how the network device can be configured. For example, this is not this is NAT-based configurations, and these are bridge-based configurations. And I showed some demonstration, including with and without KVM. But at this time, I didn't not so much about hypervisor and KVM. So today, I'd like to show more internal. So what is a hypervisor? So maybe you might know so hypervisor is a type of computer software, and we can create and run the virtual machines. And so you can present guest OS as a virtual operating system. But very important thing is unlike emulator, so the guest execute most instruction on their native hardware. So this might be very good, how to say, good for testing because most of the interactions and runs are without emulation, so very quick. But sometimes if we access the device server, it changes to a hypervisor, and so some overhead happens actually. And this is a KVM. So what a KVM is. So as you might know, so KVM is open source virtualization module in the NuttX and allows Linux as a function as a hypervisor. But it needs a hardware extension, virtualization extension. And for example, x86 and ARM and PowerPC supports these extensions. So we can run, for example, NuttX as a KVM guest, and these guest OS can actually run on this virtual CPU, but this virtual CPU is mapped via hypervisor, and to run on actual CPU, so physical CPU. And there is a, you might know, NuttX has some target configurations. So maybe most of you are using actual, so real board. For example, Cyber 6 squared is a NXP i.MX series, and presence, as you know, and ESP32. This is extensor architectures, and of course, you might use some STM32 related boards. And other targets you might not know, but there is some targets like simulator and QEMU. So QEMU was divided into two categories. So one is without hypervisor, and one is with hypervisor. So so simulator, you can use both x86 64 architecture as well as ARM64 architecture. And with QEMU, you can, for example, there is these configurations, but with hypervisors, only two targets is currently available. So one is QEMU Intel 64. This was maybe added 3 or 4 years ago, but very limited. And last year, I added this QEMU with 8A to test our some devices, including networking and block devices. And these are differences between each target. So real board is, of course, we need a real board. So we need to buy, or we need a, but and we cannot use multiple NuttX instances on the board. So you need to buy. if you want to run multiple NuttX targets, you need to buy more boards. But simulator and the QEMU, both QEMU's targets, so we don't need actual real targets. And of course, we can use multiple instances. Yeah. But there's some differences between from real boards. For example, simulator, as you might not know, booting and context switch and interrupt and signal handling, these internal code is little different from actual real target, real board. And as you might know, QEMU without the hypervisor uses a so-called TCG. This is a tiny code generator is used. So for example, if you run a RISC-V related RISC-V based NuttX code on x86 machine, this QEMU, this tiny code generator transcode, so on the fly. So this RISC-V code onto our target machines. So this, in this case, x86, and so this will be our overhead, and not so fast, but it depends on our target hardware configurations. Yeah, actually, Cortex M3 is maybe very fast to emulate, but maybe Cortex A9 with MMU and maybe slower than actual board. And with hypervisors, yeah, as I said, interactions with hypervisor happens so when accessing actual hardware, but most of the code run very quickly, and so there's no translation. And last year I introduced a BART.io, and QEMU with that hypervisor might use BART.io drivers, but some targets, for example, as you know, ESP32, these this target can use same drivers on both real board and QEMU, and yeah, actually other this Cyber 6 squad is also same, so we can use the same target drivers on both real board and QEMU. And with hypervisors, we usually use BAT-IO-based drivers because there is no full driver emulation at this time. So most users will use BAT-IO-based drivers. So this is BAT-IO support status in the latest QEMU, so QEMU 9.0.0. So last year, I also showed this slide, but at that time, QEMU version was 7.2 or something. And after that, QEMU added some features, so like audio. Yeah, this audio feature has finally merged in QEMU 8.2.0, I think. And yeah, actually, most of BAT-IO types are supported the latest QEMU, but some of devices are still not supported yet. And this is an update since NuttX 2023. So I did this kind of sent a pull request and finally merged. So first I added the BAT-IO sound, and this driver was contributed by Xiaomi. So I again thanks for Xiaomi that they contributed this driver to our community, but there is no configuration to test this BAT-IO sound driver. So that's why I added this configuration to both on an RB bird. So this is a RISC-V target, and this is a QEMU with 8A, so ARM64 targets. And at the time, I tested with this, Raspberry Pi 3B Plus, and it works. And then I bought a new, not so new, but Raspberry Pi 4B. But soon I found that it crashed actually, and I investigated why it crashed, and finally found that this GIC V2, generic interrupt controller version 2, so detection scheme code is there is a bug in this detection code. So I finally fixed and finally works on Raspberry Pi 4B as well. And then I added an NX recorder to record the audio. So yeah, actually I first tested only the playback. Then I added the recorder to record the audio signal. And then I said QEMU version was changed from 7.2 and 9.0.0, so which was released on April this year. This is the hypervisor support, and actually when I talked last year, I didn't too much about this topics. And yeah, actually the QEMU ARM64 configurations originally we use GIC version 3, but we need to use the GIC version 2 for hypervisors. This is why, for example, so Raspberry 3B Plus is has a proper controller. Raspberry Pi 4B uses a GIC V2, and this MacBook Pro uses Apple interrupt controller. But this is very important. GIC V2 emulation is not only supported in QEMU Plus hypervisors. So that's why we don't use a GIC V3 for hypervisors environment. And also, I need to change to use HBC hypervisor core for PSCI. PSCI is used to boot secondary processors. As we talked before, NuttX supports SMP, so symmetrical multiprocessing. So if we need to boot the secondary processors on hypervisors environment, so we need to use this PSC, this PSC interface. But to call a PSCI, we need to use the HBC instruction. So this code stack shows how secondary processor boots, and you can see this HBC code instruction. And Also, we need to start ER1. So ER1 is exception level 1. This shows us means OS, run OS, and instead of ER2, because nested virtualization is currently not supported. So that's why we need to use, we don't need to use this option for QEMU. And this is running as a virtualized sound without USB audio. So we can use these configurations, and you can set these parameters options for QEMU. So for Raspberry Pi 3B and 4B. So you just you need to add you need to specify audio depth as answer, and but as you can see, this is I executed Lcode command to see which devices card is available. But unfortunately, original Raspberry Pi does not support the audio input. So that's why I need to add I need to use a USB audio device. This will be covered in next slide. And as for MacBook Pro, so we need to specify a core audio instead of Arthur. But this backend only supports playbacks. So yeah, so we cannot use our audio input with MacBook Pro at this time. Yeah, this is with USB audio device. You can use the same configurations, and you can use, for example, this is audio device which I use. In this case, we need to, the card is detected like this. So as you can see, A record minus L and A prime minus L. So you can see both card is detected. So that's why this means that we can use audio input if we use this kind of USB audio device. And for example, this audio device has multiple input port, so we need to change a capture source. For example, this is a change to line, and also maybe we need to change the capture volume as well. This is a performance comparison with Hypervisor. I think I showed maybe same slides before last year, but I changed my environment. So I'm using the latest NuttX, so which was released on this April. And actually we changed the Web server version and Mac OS version. And also I changed the compiler version as well. And these are numbers for so far as get prime. This is to find the prime number to check performance, just CPU performance. Maybe so this is with a hypervisor, and this is with hypervisor, and maybe around 4 or 5 or 6 times is faster. So with hypervisors, and this is IPER, so network performance numbers, and so one is without hypervisor, and targets is client mode and server mode, and yeah, actually, let's say speed is not so high just compared to get prime, because it needs to access actual hardware, and in this case, there is hypervisors overhead happens, and this is a very interesting approach, not approach, but I found that this path command is very useful for to debug the hypervisors as well. So maybe you might know path command. This is a performance analysis tool, and there is a PMU, as you might know, and but you can use collect guest OS information as well. And for example, this shows a code stack, and and when I run IPAF-C, and with KVM KVM top commands, and as you can see, there is a bottlenecks in memcopy and checksum. So maybe we need to optimize these functions to improve more performance. So when sending and receiving packets, yeah. But as I noted, obtaining the code graph is on the guest OS is still not supported. But maybe future there is some patches for only Intel architectures. But maybe soon, I believe, ARM64 architecture, some guys will contribute to support this feature. And so finally, I show demo videos, and so I use this environment, so Raspberry Pi 4B plus audio device, and so guest OS, as I said, on the latest NuttX release, and I change the config schedule TKS Y because original upstream code you do not use a schedule TKS, but if we check such a call stack, timer interrupt, it's very annoying to show a call stack. And I prepared two kind of scenarios. First one is just iPerf, and one is NX recorder and NX player. Okay, and change to let me change. And okay, let me. Okay, GT. Oh, loopback. So which? Oh, loopback audio. It's okay. Oh, I forgot to check loopback. And use a map. It's okay. Yes. Okay. Oh. Anyway, let me try to Perhaps there's no sound online, but let me try. And this is. So right one side, we use this side shows a park command, and then start as QEMU. Maybe it's small font, sorry. And but there's no activities on right side because the first one is without hypervisors, so we cannot detect guest OS. And then just sending a packet, and maybe speed is around 43 megabps, and then change your with hypervisors and start just change the directory to KVM. Yeah, you can see here some activities on with Spark command. Yeah. And then, this is SMP applications. And then down our iPerf. So you can see it almost the same code stacks, and you can mem copy and actually, so that is bottlenecks for we can find. So this is the first demo video, and then this is the second demo video, and actually I work IO top command to see actual IO activities, and so first adding mounting a device, and then start recording, I think. So maybe, sorry, small font, but you will see these activities. Yeah, maybe soon start our audio recording. Yeah, you can see it. This is our write activity. So currently, you can also see some fast access control. And so actually, audio recording is working, and file is created. And then, yeah, actually stop recording, and then drop the cache. So before starting the next player, because so with caching, we cannot see any audio read. So then that next player. Yeah, actually, the sound is hearing from my MacBook, and you can see here actually read operation is happening on host devices. Yes. So that's all. So thank you for watching.
Thank you very much. Can we take questions?
Do you have any questions?
Yes.
Yes, please.
If you can go back on the slides when you had the comparison between different
different types.
Yes, and performance. You mentioned that you are testing now on the latest version of NuttX with the latest compiler. Do you have those numbers for a previous version of NuttX with previous compiler versions?
So maybe you're talking about this,
Yes.
right?
Yes.
Yes, actually, I have the numbers in previous workshop, but at that time, yeah, actually, the code base was very old, and so as I explained in previous workshop, my original driver was not so optimized, and then Xiaomi people developed a new framework for Bad.io driver just for networking, and then improved much for networking. But maybe, for example, so get climb. This is, I think, this shows only so CPU's performance, not for networking or such performance. So maybe these numbers, I guess, it's almost same, but this number is different. Yeah. So depends on the which driver and which framework we are using. Yeah.
I see. I think that this kind of measurement would be really good if we can test with the same toolchain and the Ubuntu version every NuttX release to see if we have a performance regression.
Yeah.
So it would be really useful to have it on the release as a testing phase.
Yeah, I think so. And actually, I found that with hypervisor's performance is slightly dropped after I upgrade the macOS version. So maybe I'm not sure if why the performance is degraded after updating my macOS, but maybe we need to investigate more. Yeah.
Also, maybe it's interesting to do the same check for the toolchain, different toolchain versions, because then we can find the regression in the toolchain, if any.
Yeah, I think so.
So I suggest that we open thread on the mailing list, and then we start collecting data. I guess that will help both us for the releases and also the other members from the community to track different issues with specific releases. Thank you very much. Very nice presentation. Okay. We have time for one more question.
I have a question about this network configuration performance. So right now, you use kind of network stuff in NuttX source code, right?
Of course.
And there is one more good architecture is existed in NuttX named user sock.
So I know. I know.
How do you, if you do this kind of performance or analysis by using the user sock, what do you plan to do that? For example, you will need to implement the user sock just for kind of the host OS stack use, for example. What do you think?
I think the user sock, as you know, is for example, as you know, we are using user sock for Wi-Fi, because Wi-Fi device has its own network stack inside, and yeah, actually we use I measured some performance with presence plus Wi-Fi before, but it might be not difficult, but maybe, for example, the Wi-Fi is very complicated. So, for example, we need to prepare the access point as well, and it, yeah, actually, might be so when some not well. Yeah, we need how to say if we need measure the numbers, we need to use a very closed room for yeah to just check the speed, I think. So it might be more difficult, I think. But just for thinking about the user sock, of course, yeah, we can use the user sock on simulator, and we use, but just for maybe looking back, I think. So I'm not sure if this performance measurement is useful or not.
Yeah, because I thought this approach is very good for kind of the managing the performance on the NuttX implementation. So user hooks also the part of the NuttX. So how to say kernel side of the user hook should be measure this kind of way to keep the performance is good. So
I agree with you. Yeah, of course. Yeah, but we need to, how to say, as I said, we need to have the testing environment we prepare. Yeah.
Okay.
And yeah, please.
Thank you. I have a question about this. Thank you for a great presentation. It's very insightful. My question is because when we use VirtIO, we need the VirtIO from driver to work in the guest OS, right?
Yes, you're right.
At present, I see you have implemented some device driver. Are there any other device driver implemented in the NuttX, such as network or web device or something like user input?
Yeah, actually, as I sorry, let me go back more right. Yeah. So last year, I talked at this right, and first I implement network driver, and then I implemented block driver, and then Xiaomi people improved so they applied a new framework, and I think they implemented as far as I know, maybe they implement input device and some kind of devices. And then, so last year, so they implemented the battery sound driver. So, but as I said in this slide, yeah, sorry, yeah, maybe. Oh, sorry. Actually, yeah, sorry. Actually, so battery driver, sound driver is implemented by, yeah, contributed by Xiaomi. Yeah. But there is no testing environment, and so, and of course, there we could not use hypervisors with battery sound driver. So that's why I created this kind of pull request to check the actual the battery sound driver test driver, so with and without hypervisors. Yeah. please.
Thank you for your talk. This time you talk about business. But there are plans for NuttX to provide hypervisor or virtualized host function.
NuttX provides virtualization function?
Yes, virtualization host function. Yes, not yes.
So you are talking about NuttX will support the hypervisor function? Okay, but in my, I think, yeah, actually, creating a hypervisor is might be not so easy. But yeah, of course, in some cases it might be easy. But if we support, for example, merge processor and MMU, and yeah, actually many CPU features, and of course ARM64 and Intel architecture, and yeah, maybe we need to re-implement such a so scheduler and hardware resource management in hypervisor. So we need to re-implement it. So this might not so useful for NuttX. Yeah.
My question is about I found Zen hypervisor.
Yeah, Zen.
They are implementing the non-zero and non-D
Yeah.
with Zephyr. So
Oh, really?
there is small topic provide virtualization information, the hypervisor and Zephyr as driver OS. So also Android is now using QNX for automotive version. So it is a new development for RTOS.
Okay. Thank you for your thank you such a good information. Yeah, we direct to check. Yeah, thank you.
Do we have any other questions from the room? Alan, do we have questions from the internet? In that case, thank you very much, Masayuki-san.
Thank you.
Very nice presentation.